morning, good afternoon, and good night, everyone. I'm Adérito Sacama, and I will be your moderator for this section. I have a bachelor degree in mechanical engineering, and I work now at Technip Energy as a subcontracting engineer. So, just to start, I would like to say to you that this presentation and this webinar will be recorded so that all of you may know. And I will start now with the presentation about this saga. For who does not know, MWE, it's a Mozambican Woman Energy, is a platform created by passionate women that aims to identify areas of action and empowerment to change the narrative of Mozambique, contributing on sustainable development of our country, increasing the number of women in energy sector, both case urban and rural areas, and highlight the professional quality of women to create equal business opportunity. We target the gender equality and equal access to energy, focusing on empowerment and supporting and inspiring a female to become future leaders of our country within an energy sector. The MWE is sustained in four main pillars. That's build. First one is think, the second one is build, and the third one is connect, and the fourth it's lead. Where all those pillar objective is to end up developing leadership programs and to give impact for the creation of young leaders, focusing on women integration into the energy sector. We are aware that not too many courses and information regarding to the energy sector. It's not available in easier sources and research. So that's why the MW have organized this all saga to make the deliver of as much as possible information to young students and graduated, so that they can understand how this sector work, and to develop their skills and background for the ones that need to enter on this sector. We have hosted on past time several episodes on the energy sectors, and to let you know as well that MWE it's now partnered by the Mozambique Guys Summit and Exhibition. That's is an annual event that has been run into partnership between the Mozambique Guys Summit and ENH. Just to give you a bit of the rules, after you enter here on this webinar, please mute yourself and turn off the camera. And during the presentation, I use the chat to do the compliments, if any, and all the questions, related question of the presentation, please raise it in a Q&A section. And later on, we will give you all the answers as much as possible. And for those that we may not have answer, we will post later on, and you will be more involved on that. So this saga will be a construction saga. As you know, we are now in EPC IC presentation phase, because the EPC IC means engineering, procurement, construction, installation, and commissioning. And this is mainly the type of contract that we may have during the tenders that used to be launched by the clients of those oil and gas projects, or other projects are related to this industry or other. So and now it's a construction one. And we have here one greatest man that will be presenting about construction. He holds a large background on this field. So let me introduce you, Christophe Paget. Please, the stage is yours.
Yes, good morning to everybody, and I'm very happy to be there tonight, and thanks to everybody who support me to make this presentation, Nancy, Talumba, and it was do it with great pleasure, and I will be very happy to share my knowledge. Just first of all, I am in Korea, in South Korea. It's 7 hours time difference, so it's the end of the afternoon here. So you can see basically the screen behind me is a little bit, end of afternoon, and there's the FLNG just at the back of my window. You can see the Coral FLNG, which is under construction, and which is the target, the sail away is the end of the year. Okay. So just a few things before to go a bit further. So I have really think a little bit how to present this construction topic to you guys, because you are young engineers, young students. So I try to make it simple for you guys. I will talk about around the slide more than the slide give you basically the fundamental, but I will speak around the slide to give you a more feeling about construction. What is construction? What are the profile we're looking for, and really what you can feel comfortable in our organization and our team. So that's will be my aim. Okay, the aim of my presentation. But again, I think the idea for me is to give you a first approach on construction, and to give you some idea where you can sit in our organization, and to work for Technip Energy, of course, which is the aim for all young engineers. Okay, all right. So what I've done is I have recorded an introduction of myself to basically to make it a bit more, I will say special. So it was done, a few days ago, and I'm going to share it with you. It will give you the idea about who I am and what I'm doing at the moment in Korea. And after we can start the presentation. Okay. Okay. The presentation will be around 40 slides. I have 3 movies at the end showing 3 projects Technip Energy did. If I took Qatar LNG, which was done a few years ago, is an onshore plant, and the Coral FLNG, which is ongoing. So I will show you 2 movies on Coral FLNG, the topside installation and the TMS installation. So you have an idea about what we can deliver as a contractor, EPC contractor, and what we do in construction. Okay. Introduction. So I'm going to launch this video. I hope it's going to work. I'll let you watch and listen. I think after we can talk about more in details. Okay. All right. Yeah, so a quick summary of my background. So I joined Technip in 2006, in 15th February, if I remember well. I joined the construction department in Technip. Since I work on different projects overseas, around 11 years almost on onshore and offshore facilities. I also participate to some tendering, job study and FEED study in Paris, 2-3 years. And before that I was also working on oil and gas project for another contractor. It was around 10 years, so it's around 25 years experience in oil and gas. Well, I think it's, I would say, a mixture of meetings, discussion with other people, presentation as well, and site visits. So it's basically the rhythm we have daily and weekly. So that's more or less what we have on this job. Because of the COVID, we have changed a little bit the way we work today. We spend a lot of time in front of the computer, dealing through Teams, and we use a lot of tools to communicate with our colleagues. But basically, it doesn't change the way we operate. We have the same kind of, daily agenda. On this job, I will say that our launching was important. Milestone when we left the last module was important. But what is probably for me the most important achievement will be the delivery of the 3 TMS modules, which were fabricated in Singapore. It was a difficult task for the team to be able to go through this COVID-19 situation, and we managed to get this module in time just before Christmas. After Christmas, it was a good present, and I think it was a good achievement for the team, and showing really our capability to
work together as a team and deliver this TMS module. So it was very important. I think the most important for me was this session. Yeah, I think it's important. We're going through the COVID-19 since 1.5 years now, almost. I think I would like to recognize my team and the effort from everyone to still focus on delivery during this time, and I think we are doing very well on this job. So again, thanks to my team, and it's really helped a lot to have this kind of people and on our job. So thanks to TGVT. Thank you.
Okay, so just to give you a bit more information. So I've been on this job since August 2019. I was mobilized from another FLNG project called Prelude in Australia. So I joined the project in August 2019, and since I'm the area manager site representative for JV. JV is a joint venture between Technip Energy and GDC of Japan, and I'm leading the team. We have today on site around 400 people. The number looks high because we also include O&M, operation maintenance team. We have commissioning and construction as well. So it's basically a big team of people. I think we have more than 40 nationalities on the project today. So that gives you a kind of, idea about the culture, the different culture we have, the mixture, and so it's very interesting to meet everybody and ready to exchange about our life, on the project and outside the project. So it's very interesting, despite the COVID-19, which has not impacted, Korea as other countries in the world, but it's still subject to, some restriction in terms of, gathering together. We have some quarantine when we enter the country, so it's still not easy to manage for some people. We have been here for many months, sometimes more than 1 year. I've not seen their family since 1 year, so it's basically sometimes a bit difficult. That's why we are here to support them. Okay, so just to come back on if I understand the process, maybe I think we're going to have the Q&A session at the end of the presentation. So that's probably be easy for everybody to record their question. After we can have 15-20 minutes, depending on the time left, to discuss more in depth about your question. I will try to answer you. Okay, first of all, I think some numbers, some facts about construction. So I think construction in terms of definition, you can go to Google and check. I just take it from Google. So it's very simple. It's basically the meaning is the art of and science to form objects, system, or organization. So basically, it's a general term which is used to make a form. And in our industry, this is basically how we put together, some system equipment to build, oil refinery, gas plant, FLNG, FPSO. That's basically the definition of construction. Okay. In terms of what is this represent in our GDP? So in 2017, this is a bit old, but that gives you a bit of idea. It was representing 10% of the global, GDP for the developed countries. It depends of the country, of course. It can be go from 10% to 50%, depending on the country and the location. But that's give you an idea of the weight of this construction and this in our business. The women in our industry. So women are not represented probably enough in our industry for some reason. It's probably considered as more a male job, but it's probably something which is changing with the time. So we have again, this number come from website. So I think I have checked, but it's more or less with what we got today. So women represent 10%, almost 10% of the gender in our industry. So it's very low number. Even if you look at the construction where people are in the front line, we probably go below this number. So that gives you already the percentage of women in our industry is very low. For Technip Energy, I give you some idea. We are more an engineering company, so we have the opportunity to employ more women, and we are targeting to have 50% of women and 50% of men in the next couple of years, and we are really getting to this number, and we are very proud of it. Okay, and the chance for us, the opportunity is to give to everybody a chance to succeed, and men, women, there is no difference. So Technip Energy welcome everybody. So I just start on a typical project phase. So we talk about EPCIC. So you've done the engineering, understood. You're going to do procurement very soon. So construction is basically another phase of the EPC project. So this is the last phase, the last phase when you basically engineering procurement is done, and we basically build and form all these, elements we have design module or brownfield, and we just build together this system. So construction is complex organization. We have a lot of elements to make it happen. So you can see a pie which give you a different, discipline and support we need to build something here. So you can see you have procurement engineering here, which is basically the part of the EPC and construction, but it's not only this. You have also other, supporting, discipline. You got communication, you got project control, admin, communication, logistic, material. So this is basically a big pie, and everything work together. If you remove one of these elements, the project will not be executed normally. So we have to make sure everything is well set up at the beginning, and this is well organized. It's very important, and this is basically the key for success on a big project. One thing which probably not highlighted, which taking more and more important, this is IT and digital in our industry. So it's you will see at the end of the presentation some slides showing what tool we are using on our project. But I think it's going to become more and more important in our project, especially digital, and I think will be becoming one of the main disciplines to support the project. Next slide. So this is, so I show you basically where the construction is and what are the support around construction we need to execute the job. This has also to be executed in sequence. You cannot build the thing until you have done your design, procurement. So there's a clear sequence to follow. And it's part of the schedule we're putting in place to execute a project. And construction installation is happening when you have already done the design, procurement, and you have received your material. So this is very important. And this is linked all the activity you have prerequisite to start the construction, where you design your plant, you buy your equipment, and you deliver your equipment. Okay, this is part of the process. You cannot do it the other way around. You cannot start the construction before you have finished your procurement, and vice versa. It's very important to follow this process. The end of the sequence is basically when you hand over your system or equipment to the commissioning team, who is normally in charge to test and make sure the equipment is working well and will be ready for operation later on. So this is basically the end of the construction installation. And this is where the construction team hand over the key to the commissioning team. For info on Prelude, we are on Coral FLNG, sorry, we are in the middle of the commissioning. So we have some overlap construction activity today, but commissioning as taking over is leading the project, and we are in the last few months where commissioning has around 200 people on site today. Contract. So we win a contract. Okay, this is through a process which is well established. We know to bid, and we have a lot of pre-qualification before, but you qualify, you submit a proposal, and you win the contract. So we have different ways to execute the contract. For some reason, Technip Energy has to team up with other partner, because sometimes the size of the project is big and too big, and we cannot execute on our own because we don't have enough resource or enough fund to finance the project. Sometimes we have to basically have a big money put in front, so we need to have a partner. So we normally used to go to choose a partner in engineering, because we're an engineering company. We choose a company who can team up with us, and we put together the resource, and this is what we call a joint venture. So on this specific project in a Coral, for instance, we have a partner with GSC of Japan, who has been a long-term partner with Technip since many years, and we execute some job together. And basically, we have a pool of resource coming from Technip Energy and GSA. We're working together on the same project, same goal, and basically deliver, engineering deliverables and drawings, calculation note, all these things. Okay, and this is basically we are together. We share, basically everybody shares the same, I would say, pot in terms of money, and we share the profit and the loss. So if JC lost money, we lost money, share between the partner of the joint venture. And normally the rules are put in the joint venture agreement, which explain who's doing what and what are basically the percentage in terms of responsibility. So joint venture is normally 50-50, so 50% for each partner, but sometimes is one partner taking the lead as more share in the joint venture. So that's for the joint venture. The consortium is different way to execute job. So as you know, we are an engineering company. So when you need to execute a job, sometimes you don't have the capability or the knowledge because you don't have equipment, you don't have any asset. So we use to team up with a yard, a specific contractor, construction contractor, and we form a consortium where normally we're doing the engineering, procurement, and the partner doing the construction. So they mobilize their resources, the equipment, execute the job. This is basically their main job, and they're doing only construction. So this is called a consortium. In this model, each entity is responsible for their own part. For instance, we're doing the engineering, we deliver to the partner and doing the construction. So everybody is responsible for their own part and also for the loss and the gain. So that's sometimes creating some issue in terms of claim. And it's happening today, this project with Samsung and Samsung Heavy Industry, which is our partner for Coral. And basically, we should give them some equipment, some engineering deliverable at a certain time. It doesn't happen, so they claim against us some delay or whatever. Okay, so that's a consortium. The last thing is a subcontractor. So on this job and other job, we always subcontract some part of the work because we cannot execute by ourselves. Same reason, no resource, no equipment. We are not specialists. That's all. We don't have all the specialty in our company, so we need to find a specialist subcontractor. So we decide to award the subcontract to a specialist company to execute a job. So we become a subcontract, and this is also linked to a call for bid. We have a process where we basically select different, bidders. We do some evaluation and we select the best bidder in terms of technical and commercial. And we engage through this subcontract to an agreement, a subcontract agreement, which basically explain what are the rule of this agreement. Next slide. So this is again, when you buy a car or you buy a house, you always have a contract which basically bound together the entities, and this is basically the main contract between the client and ourselves. Contract are always the same type of document. You have a legal document, term and condition. We explain what are the rules which will apply for this contract. Okay, depending on the country, depending on the conditions. You have a commercial part, which basically explains the schedule. We always have a schedule linked to this contract. We have to deliver something at a certain time. Of course, price, because we're bidding for job. We have sometimes lump sum, reimbursable. So there's some commercial elements which are part of the contract. We deliver this for a certain amount of money. So this is the commercial side. We also have a technical side. We are on oil and gas. Have to comply with specification, with a specific, client requirements. So this is basically a set of documents which explain what we need to deliver in terms of performance, a technical requirement, and specification. So this is sometimes, a lot of documents to be read, and a lot of pages. This is very important because where I think we can make a difference in terms of, I would say delivery of the project. By make sure we comply with the contract, and we basically avoid too much claim or too much issue during the contract execution. Once the job has been awarded, so we have signed the contract, so we execute the job. So normally, as you have seen before, the project has the engineering procurement phase, which is happening normally in an office somewhere. It can be the office of Technip Energy in Paris, or with our partner in Japan or somewhere else in the world. So we're doing the engineering procurement. And during this time, the construction start to be involved and start to work with engineering procurement to explain what are the requirements for construction. This is happening, and this is always the same scheme. So engineering, procurement, and construction. Once we have basically reached a certain time, and when the schedule has defined the starting date of the construction, we mobilize the people on site, and the team of managers mobilize to site. So this is what is represented in blue in this slide. This is a typical organization for, I would say, onshore gas project, but you also can apply to offshore oil project. It's basically the same, more or less the same. Even it can apply to other industry as well. Okay, so you will see these people mobilize some at early stage of the project. Then later they move to the site for execution of the project. So you will find always a HSE manager, who is basically take care of the HSE part of the project. Project control, commercial side contract is very important. Construction manager will be the key person in terms of construction, but he's you cannot see, but he has a lot of engineering support here and superintendent to basically follow the construction in the field. The site logistic we have seen in the pie before. The logistic is also a very important part of this EPC phase. So we have also this manager mobilized on site. Quality manager, we'll see later that, and we have seen the contract basically refer to specifications. So we have to make sure we deliver as per the specification of the project, the client requirements. Site admin and business manager. So also we have a lot of people to manage on site. I was talking about 400 people on core FLNG. So you can imagine in terms of mobilization, in terms of visa, in terms of logistic, what does it represent? So it's a big job. And we have a team of 10 people who are basically managing all the people in the field on site. Field engineering manager. So the engineering is done basically before to start the construction. However, because we are always dealing with prototype project, you're always dealing with modification, with some things to be changed in a site because there's sometimes some change in terms of routing or things like this. So we have always a field engineering team on site to be able to accept a modification to be done due to some change. So this is a key also activity in the construction to support the construction to make sure we are not stopped by engineering issues. Again, the engineering is done in previous before the construction is done on a model. And you always have some kind of mistakes. It's human mistake where nothing is not. You don't have all the information sometime, and you have to deal with basically unforeseen things, and you have to accommodate on site. So we have the field engineering manager. We're dealing with this change. Subcontract manager. So again, we back to the subcontract. We have to subcontract a lot of activities, and he's a key person as well because he's dealing with a lot of subcontractors, and also there's a lot of money involved in this topic. So it's a big position on the project. Finally, this is what I explained, the handover of the construction to the next phase, which is commissioning, pre-commissioning, commissioning. So this is also managed by a manager. Make sure that before we hand over all this work to the commissioning, everything is done as per the book, and they are ready to take over all the system and the equipment we have finished to build. Okay, so a zoom on construction activity. So what I explained before, so construction activity is in the field, we have the team mobilized, and what's happening is the field is what is in orange on the right. However, construction start earlier, and more on this project, you can see the construction started to be involved in a bidding stage, contract award, to make sure that they are part of the decision process, and we have to make sure they have the right to basically explain what they want in terms of engineering procurement. So this preparation activity happening sometimes in your own office, in a home office, where you prepare your job, or when you start your job, when you have all the EPC engineering procurement. So you're doing the constructability studies, which basically will set up all the information you need to collate to prepare your construction. It will define the construction sequence and basically give it to the planning team to build the detailed schedule. It also makes the evaluation of the resource to execute the job and the cost as well, because resource means cost. So we give you the number of people we need to execute the job, which will be used for the design of the temporary site facilities. So in this case, we're talking about onshore gas project or a project where we have to work in an area which is basically sometimes remote. So we have to build the site facilities and we have to accommodate all the people on site. Of course, this is something which is also done, and I'm doing this at the moment for Core Life LNGs. We are doing some kind of feedback on the project, the issue we have on site, and what we should do to improve it. So this is also a big element we have to consider when we do these studies and preparation activities. We make sure we use all the feedback from previous project, and we just improve our method and the way we build to avoid the same mistake. Okay? Site activity, so it's basically quite simple. So when we have basically the people more or less on site and we have the contract awarded, so we have first to comply with HSE objectives. It's very important in our industry. We're dealing with a lot of high-risk activities. So we have to meet HSE objective. Quality standard, again, same thing. We have specification, we have technical requirement. We have to comply with the quality standard. Supervision, it's a big one. Is basically we have in the construction organization on site, we have probably 50% of the workforce of the people is into construction supervision in the different field. It can be, you'll see later, the different discipline and we have during the construction activities. We also have to coordinate with the subcontractors and all the disciplines. So this is mainly when you have a planning, is we need to make sure that it's happening in a sequence to make sure that nothing can stop another subcontractor, another activity. Progress monitoring, again, the contract gives you a schedule to deliver something. So we have to track and monitor our schedule and our progress to see if we are on track, but also to get paid, because we need to get paid by the client. So we use this to monitor this site activity, monitor the progress, and we can claim the money from the clients. Material also is an important task to be done. We buy material, buy equipment from all around the world, and we have to ship it to the site. So we have a big team on site. We're basically receiving the equipment, store it, preserve it, and give it to the subcontractor. This is one of the main activity for the site team. Okay, a zoom on the preparation activity. I think it's become more and more, I would say, important to start the construction activity preparation early stage. What we are doing now, this is in a lot of companies we do it. We're doing a kind of workshop where we do a construction activity review, is to basically integrate all the requirements from everyone, the client, the planning team, and to make sure we can deliver the planning as per the schedule we have agreed before. So I just show you probably all the things. This is better. Okay. So you go in the middle of this workshop, which is happening. You can set up your workshop during the preparation of the contract, when the contract is sign up, or after sign off. Sorry. So basically, you run different workshops depending on the discipline, different the complexity, different the subcontractor, and basically you have to use the feedback from previous project. You also are using specific tools, decision tool, role and responsibility tools to prepare this workshop. You have the client input. Client, as always, and normally is invited to this workshop, as are always some specific requirement in terms of the way they want to build the plant. And you got, of course, on the right, this is a construction and pre-commissioning input. Pre-commissioning request to start in a specific sequence, which is needed by construction to establish the way they want to build their project. So once we have done this workshop, we deliver a constructive matrix, which will give for each, I would say, discipline, all the actions they have to follow to deliver this project. This is quite demanding. It involves a lot of time, a lot of people. Sometimes it's done. It can be done on a few months, But this is something which is done in Technip Energy now on all the projects. This is a kind of Bible, and we can use it for all of the projects, and we can, of course, reapply for the project, but we have to re-inject the new requirements from the client, from the commissioning. But this is basically a process very, very well known today, and this is the key to deliver the construction schedule. Another thing which is very important, which is different from what we used to do many years ago, is before the construction was mobilized late. And only when the engineering was done or procurement was started, which basically was given no much opportunity for the construction people to get familiar with the site, look at the engineering drawings, and basically make some adjustments. We learned from that, and we have changed a little bit the way we operate today. And we normally mobilize construction, as I explained before, very early to provide input to the planning and to the engineering and procurement. So in fact, we're going to ask engineering this specific information at a certain timing. We want this to be done this way. We want this equipment to be delivered on this specific date. We want this equipment to be designed like this because it's easy for installation. So this is an important, step as well, because it's going to optimize the construction and help to achieve the schedule by putting a specific requirement on engineering and procurement to make sure that we can do the construction as per the schedule, and of course try to improve the construction schedule, try to save some money as well by using different methodology for installation or for fabrication. So this is also a different approach, but this is now very common in Technip Energy, is to have the construction manager to be involved in the design study, design and review, to provide all this information, and it can really focus on construction, but for sure, you will have all the information you need to start the construction. So this is also an important task, and you will probably be involved in this kind of session where you're doing this design review, where construction people are attending the design review to provide their requirements. So subcontracting activities, so same as construction, so we start earlier. But earlier than construction, because of course we need to define the package very early to place the contract, subcontract. So this is something we're starting at the contract award. Mobilize the subcontract manager with subcontract engineers. We start to prepare the cost estimation with the construction support, and prepare the subcontract package, which is basically some documents we have seen before. You have the legal document, you have the schedule, price, and you have also the technical requirements. So this is done through a process very well established. We call for bidding after pre-qualification. We receive the bid, we analyze the bid, technical evaluation, commercial evaluation, and we award the contract. This is done at early stage of the project. You can also imagine that this is important to have all the information quantities on to help the subcontractor to build their price and the schedule, and also to be able to leave enough time to the subcontractor to buy what they need for the job. So we do it very quickly, and this is becoming a critical task for the project to mobilize the subcontractors as soon as possible. Site activities, once the contract is in place, so we have on site some subcontract engineer. We administer the contract and follow the contract in terms of claim, schedule, legal, and are here to make sure that we stay in the subcontract agreement, as a subcontractor deliver what has been agreed in the contract, in the subcontract agreement. Okay. Today on this specific job, we have with Samsung Heavy Industry, we have 80% of the construction is done by Samsung, and we still have some subcontract for smaller job. The 2 MOA system was fabricated by Sofec in Singapore. It was a subcontractor, but we have also some local subcontractors here. We're working on smaller job on the package delivered by Technip Energy GGC, and they help us for the finishing of the package. So this is we have around 10, 12 subcontractors here local. We're doing this activity of supporting the construction. Depending on the project, you will see we can have many more subcontractors, or even sometimes one with basically a general subcontractor doing all the discipline. Next one is another thing which is very important today is when you sign a contract, there's a lot of documents to be prepared for project and construction. So we talk about a lot of procedures to explain how you're going to execute the job, how you're going to build the plant. So this is an important task which is also done by the construction team. We help to build the construction procedure, also participate to the project procedure. So this is a big job. And this is where we need people to be mobilized at the early stage of the project. Construction procedure, same, we talk about sometimes 150, 200 procedure for one project. It's a very detailed document. So we can see on the screen, this is a welding procedure. This is really explained in details what as job has to be done. And this is something like a step-by-step, procedure to explain how to install equipment or build a plant. All these documents are administered by a database, electronic database today, which is used, for to communicate with all the stakeholders. So we're talking about, I say 100 procedure, but also we have maybe sometimes 1,000 drawings. We have a lot of calculation notes, so becoming, really a big part of documents. And this is managed electronically by a database, and which interface with all the vendors, engineering and correspondence with the client. So this is used for sharing information, but also get approval. So we have a system in place to get signature, to get approval. And this is the way we administrate the procedure and of the project. So this is a big thing. And on the job here, we have around 2-3 people. We are working full time on this doc control process. So this is a key also part of this site activities to make sure all the documents are well shared with everybody, and we have all documents approved before to start any activities. So I'm going to go through now a bit of detail of what we normally have on a project, typical project. I'm talking about onshore project here, but you can see that I can apply to other project as well. It gives you basically what kind of subcontract you have, what discipline, and basically imagine a subcontract for a specific activity and a supervisor which supervise these jobs. That's a typical, the breakdown of activities in for onshore gas plant or refinery. Earthwork. So most of the time we are entering, grass field is basically a green field, which is basically a kind of land which has been purchased by the client to build a new plant, and we have to do all the landscaping. So this is the first activity. The earthworks is to make sure we have all the platform have the right elevation, the right, I would say bearing capacity. This is the first activity you start. And this is normally also specialist subcontractor, as you can imagine. It cannot be done by anyone. You have to employ specialist people, especially specific equipment. So this is something also which is a specialty job. Next task normally you're going through is a pipeline installation. So this plant normally is filled with utilities, water, gas, whatever. So we have a big pipeline network. We're bringing, we feed the plant with all these utilities. So this is also something which is done at the beginning, and this is a special subcontractor. Sometimes the pipeline is already installed. We're just doing a tie-in to the existing pipeline, but also in the new plant you build the pipelines from at the beginning of the installation of the facilities. Roads. So of course we need the roads to go around the plant, access the equipment. So this is also a scope which is specific and part of the contract and subcontract we have to implement on site for construction. Again, special subcontractor, it can be done by people and who got the right equipment and the right expertise. Next one, building. So again, plant means we have to have offices. We have to have an area where people can work on the computers. So we have to build a kind of specific area where they can work. So we're doing buildings, steel structure or concrete structure. Again, specialist subcontractor, specialist people who supervise the job. So no difference, is the same thing. And the road or the pipeline. Civil works. the basics. So everything is installed on foundation. So before to start anything, you have to do your civil works foundation, which is done underground. And this is one of the first tasks to be done. Sometimes it's done in parallel with the earthwork, sometimes just after, but this is also in sequence. We define the time when we're going to do the civil works. So this is also especially subcontractor. Underground network. This is a critical task because it's always difficult to work at the beginning of the project when you have all this trench open. So this is important to plan it very carefully, the sequence, the timing, make sure it doesn't clash with other activities. So this is done at various stages of the project when we have basically access the site, where we start the earthwork. So we have basically the right level. We start to install the underground networks. It's normally done in the same time as the pipeline. Underground networks is all the networks which distribute the utility and the process in the plant. Steel structure. So most of the time, equipment are installed on steel structure. This is also one activity which is sometimes combined with the civil works. Sometimes it's separate, depends of the project, of the subcontractor, but it could be also put in one specific package which includes civil and steel structure. Equipment installation. So this is becoming more our Technip Energy specialties. Basically, we have buy the equipment, process utilities, and we install it. So is where we start to get really involved in terms of construction. Normally, we have our team who is there when the equipment is delivered at site and follow all the phase from the delivery to the installation to make sure the equipment is installed correctly. And we have a supervisor sometimes which are directly working for Technip, who's supervising this equipment installation. Again, this is a big scope. Sometimes we're dealing with 100 of equipment. Sometimes equipment are 100 tons and even more. So we're dealing with a very expensive equipment. Very difficult to install. It involves a lot of cranes, a lot of heavy lift equipment. So this is a very critical task. Again, especially subcontractor, which is selected for this job because it involves a very high risk activity. Piping prefabrication. So you will see in the oil and gas industry, the piping is the heart of the construction. Is where basically it's always the more time consuming, the more difficult. It's where the delay may occurs because if some equipment are missing. Imagine if you have one valve missing or a fitting missing, it can delay the job. So this is the most important activity for sure. It's where I think all the energy is concentrated. It's once you have installed your equipment on site, you have to link your equipment and install this piping. So we talk about all kind of pipe, steel carbon pipe, exotic carbon steel pipe, all kind of material, all kind of thickness, all kind of pipes. So this is really a big job, and we normally use a specialist subcontractor for this job, which is done in 2 steps. Fabrication in a workshop, where we try to fabricate as much as we can, because the idea is to arrive in the field and to install it and minimize the installation time. So we do the maximum of prefabrication in the field, in a workshop, sorry. And once it's done, we, based on the transportation requirements, we fabricate spool, 3 meters, 4 meters, 5 ton, 10 ton, and we transport it to the site. We do the final assembly in the field with cranes, but that's the most important activity in this kind of project. Piping erection, I just explained. So once the spool has been fabricated, it's sent to the site and installed to link all the equipment together and start to build the network. This pipe is normally tested after installation to make sure of the integrity of the piping system before to introduce hydrocarbons. All this equipment and pipeline piping have to be controlled for temperature, pressure. We're dealing a lot with high risk, fluid. So we have a lot of instruments which is installed to check all these parameters and make sure that the plant operate normally. This is normally all this is managed through a control room, central control room, or different control room in the plant, where all the information are reported and everything can be flagged if some issue in terms of operation. Cable pulling. So we done piping, cable pulling. Also, the big part of the job is all the electrical equipment has to be fed by cable. So we have to pull cable. This is done on the ground or on the pipe rack. It depends on the project. This is also activity which is especially subcontractor, which is involve cable pulling and cable termination, where basically we terminate the cable to a motor or to a switch gear. That's also an activity which is important for the job. And of course, all is tested before to be handed over to the commissioning. We're doing a check to make sure of the integrity of the cable. Technical room. So again, we're talking about all this electrical instrumentation. We need to be fit to an electrical technical rooms. So this is done through cabinet, which supplies the power to this instrument and this equipment in the electrical equipment. This is normally also inside a building, in a plant, in the facilities. Okay, and just instrument is one thing, but we have also some other equipment like the lighting, the personnel announcement, the general announcement in the facility, which is normally the normal things for communication. So this is also some activity which are done normally as part of the instrument. Normally it's the same subcontractor as the instrument we're doing this job. Control room, I explained before, it's where all the information are shown on the screen, where the operator can monitor and identify any issues. He can also regulate the production from the central room. Normally it's one central room, and sometimes, depending on the size of the plant, you have different central room. And of course, high qualified people are in this control room, and they are the person who will operate the plant and make sure the plant is safe in terms of production. Last thing is something which also is appear on some project is we are trying to minimize this interface and the coordination. So we try to combine together the subcontracts. We have seen today we have at least 10, 12 subcontracts in terms of discipline. So the idea is to try to put together a package to minimize the interface and optimize the sequence. It's basically important as well for the construction manager to make sure that all the subcontractors can work together and not, I would say, creating issue in terms of sequence. And so we try also to minimize the number of subcontracts. And sometimes we also take only one, what we call general contractor, who execute all the discipline in the plant. This is happening for some job, but it's difficult to find. But we try to do it in some onshore plant in the Middle East. Quality control. So in a contract, as you have seen, we have a lot of technical requirements. So when you buy something and you buy something based on some specification, and you want to make sure that what you have received is what you have purchased is have complied with the specification. So for that, we have on site the quality control manager who make sure that what is delivered is as per the specification, as per the contract requirements, as per the client requirements. So we have inspection and test plan, control plan, we call it as well. We list, all the technical requirements we need to have for a specific equipment. So this is a document prepared during the construction preparation in the head office, in the home office, and we use it to monitor the construction progress. And it's part of the dossier. You when you hand over your equipment, your system to the commissioning, normally you put together a package which includes all the quality control plan, which includes check sheet for each equipment, which lists all the information in terms of compliance of the equipment with the specification. This is give you a standard for concrete in this specific slide. This is we refer to specification standard. Can be British standard, American standard. For guys is maybe API or STM. So we're using this standard. We have to comply with this standard. And this is the role of the quality manager to make sure that this equipment, this system is delivered as per the standard set by the contract. On site, we have a quality manager, and normally he has 10 to 15 inspectors who are in the field and basically witness inspection and make sure that what has been built is as per the specification, the contract requirements. Schedule. So we have seen the schedule is part of the contract. So we have to deliver a piece of work at a certain time. And a schedule normally is attached to the contract, which gives you the main milestone in terms of delivery. Once the contract is signed, you have to develop a detailed schedule. First to basically assess your progress, your measurement, your progress, but also to be able to identify all the sequence and share with your subcontractors because they have to execute the job as per this schedule. So we develop this schedule in the office after we monitor the implementation in the field. Okay, this is what we have seen. This is level 1. Normally, when we go in the construction stage, we go to level 4, which give you a very, very detailed definition of the task to really see if there's any issue in the delivery of the task, and you develop the schedule for a subcontractor to show him really the detail of his activity on daily basis. Once the schedule has been developed, we monitor the progress. This is important to see if we are on track. It's also used for the payment. This is one of the tools we use for the payment based on the progress. So we define the weight of the task. Could be a weight with the quantities or per hours. It depends on the project or the client requirements. So we define basically for each activity a weight, a quantity to be monitored. It can be a meter, it can be hours, kilo, whatever. And we put this in a nice table, and we develop a S curve, which will give you your plan, which to deliver your project in time. So basically starting date and date as per the contract requirements. You got in green, which is a forecast curve, which is taking into account all the, I would say, change you can have it in the field, and due to the late start or an equipment which is delivered late or some resource not available. So you do your forecast and you monitor against this forecast. But of course, the aim is to have the forecast to finish as per the plan at the end. And every week, every month, we track the progress using the tool here. We basically say we have achieved so many man hours or so many quantities. So basically, this is where we are today. And you will see if we are late or we are in the plan. This is what we call S curve. The tool for that use is you can use, of course, Excel, but Excel is a little bit obsolete. We have Microsoft Project Primavera, which is the main tool used on the project today to monitor this schedule. And this is linked all the progress and the claim as well. Okay. Claim is talking about the payment from the client. IT, so I think it's something which I explained before is taking more and more, place in our industry because it's the only way we can be more optimized, more our design, more the way we communicate and we exchange information. So many years ago, 15 years ago, we used to have a 2D drawings, which is just a drawing you have. Imagine you have showing, the building, the piping. So it was a very simple things, and for that it was done in using different tool. And in the last, few years, we developed 3D model. So it changed a lot in our industry, and now we can really visualize, the plant as in reality, and we can really see and basically be able to go inside the model and analyze the clash, do the engineering based on all the environment. So it's something which changed a lot of our industries. This is in place on Coral FLNG. It has been used on previous project before. It works well. And now the idea is to link the data with the 3D. So the idea is to have all the engineering information which is captured in the specification, in the procedure, on other means are basically appearing in the 3D model. So we have TechTip is working on different, solution. I will show you later the tool we are developing for that. But the idea is to have one single, 3D model where all the information is captured. You don't need to go through 10 drawings or specification or documents from vendors. It will show you all the information on one system. By just clicking on the image, you will be able to access all these documents. IT is used, as I explained, the 3D model is developed by the engineering at the beginning and is used all along the project for procurement until the delivery on site. So the 3D model will give you all the information on the material you have to procure. It will be basically sent to procurement, which will buy the material. The material will be identified in a vendor, with a supplier. It will be tagged, marked, sent to the site, and delivered in a warehouse where it will be received and inspected, and it will be entered in our system. So there's a full traceability from engineering to the construction stage, where for instance, one equipment has a tag, which is identified by engineering here, and the tag will be basically used all along the project until the construction installation is fully installed in the field to track it and to really look at the detail of this equipment. It also used as well for preservation. We'll see later one of the tool we have developed for preservation of the equipment, but this is basically all this supply chain from engineering to construction, which is used this 3D model to identify, the equipment or whatever, piping material we have to purchase. Construction tool. So TechTip Energy has since many years, developed our own tool because we want to be fully independent. So we have started to look at different options, and we have developed a different tool today, which is based on EasyPlant, which is, you can see here. So this is the kind of development we are going through, is to have an integrated tool. We can capture all the other tools which are coming through the vendors, through the other supplier like Primavera, Aveva, which is database management for the instrumentation. So we are trying to have one integrated suite to have all this information in one single system. EasyPlant. So TechTip Energy has developed EasyPlant since 10 years now, and is becoming one of our integrated tools for the project. So this is used for Coral FLNG. It was used before for Prelude, for Yamal. It's a tool which allows you to basically follow your project from engineering to delivery. So include 3D model, Smart Plan, which is a material tools to monitor and tracking the material. Aveva, the field engineering, the instrumentation, sorry. Oracle, this is Primavera. This is also one of the planning tool. Preservation check sheet as well, which is once the equipment has been purchased, it has to be tracked in terms of preservation. So this is also one of the applications we have today in EasyPlant. Quality inspection, again, is done now more or less more electronically, where the inspector go in the field and basically inspect the equipment, and with a small tool, a smartphone or a tablet, is able to record, and the information, and directly go to EasyPlant. And the subcontractor progress and monitoring and reporting as well, which is used. So in fact, you cannot see it, but we have developed a tool which give you a 3D progress in the field. So we can, using different colors and different way, look at the progress in terms of piping. For instance, we can see how many spool has been installed, going to the 3D model. So this is something which has been used on previous project, which is not used for this project because this is done by Samsung during the construction, but this is done by other project. This is a 3D visualization of the progress. We show with where we are in terms of activity and progress. Okay. Material, it's a key part of the construction. We need material to build the plant. So we use SPMAT, smart plant material, which is called SPMAT. It has been used for Technip for 20 years now. This is a tool which is a database, which is when you create your tag during the engineering phase, it tracks all your equipment from the PO to the delivery at site. This is done through a database which has been used, many years ago by Technip. So this is in place for Coral FNG. We have 1,000 tons of material. We have 10,000 tons of piping, purchase valves, fittings, and this is all managed through this database. So you can, at any time of the I would say the week, you can know where the equipment, where is this specific spool. Is it in transit from the vendor to the site? Is it stored in the subcontractor's premises? Is it well preserved? What are the status of the preservation? Has it been installed? So we can really give you a full history of the equipment and traceability, and this is our main material management tool today for Technip Energy. Safety. So a few slides showing safety. So safety is important in our industry. As you can imagine, we're dealing with high risk activity, high pressure fluid, energized equipment, thousands of voltage. So we have safety is really part of the construction management, and we have again a lot of safety people involved in the project from the beginning until the end. And this is also one of the main criteria for contract award by many clients. They look at the safety performance of the contractors, subcontractors, and they are really looking at any issue in terms of safety. So this is becoming a criteria for selection for calling for bid. Just showing an example of safety items. So again, we're dealing with high pressure fluid energy equipment. So looking at, you have seen we are working at high, and we have a lot of equipment installed very high on the foundation. So we need to have scaffolding. Scaffolding is a big component of the safety. There is a lot of standard and procedure to be prepared for that. And we normally mobilize for this scaffolding activity specific HSE specialists who are taking care of the scaffolding. But it's also applied to other disciplines for safety, for instance, for confined space, for NDT, for hydro tests. We always have someone which specializes in this kind of high-risk activity. And this is also not on this job because we are not doing the construction directly, but on the job done by Technip Energy, we have sometimes 10, 15, 20 safety officers in the field under the management of safety manager, which are here to look after the people, safety. Human resource. So I give you a little bit of typical career path, I would say, for a young engineer, which is going out of the university and wants to progress. So normally in Technip Energy, but you can imagine the same for other companies. We talk about 25 years old. You go out from the university. You have 3-5 years of as an engineer, process or whatever. It can be civil, mechanical, whatever. Then after that, if you are successful, you go to a project engineer role. Project engineer is basically looking after different functions. He's more, looking after an area where he's in charge of all the disciplines. And if you continue and you're doing well, you can become engineering manager and deputy project manager. It's a typical way it works in Technip Energy. So this is what's happening. After that, for the best, you can become project manager. When you have gained experience and you have really show your capability, you can become at 40 to 45 years old project manager. Okay. So after that, you got project director, but this is something which is really, something which continue. If you are really a good project manager, you are very successful, you can become project director. So that gives you a little bit the career path you can have if you want to go to this industry, and we want you to join us. But this is also a kind of way to progress, and it show you the potential you can have in terms of career development in this industry and technique energy. Okay. Next slide is I put some. I want to share some movies of project I've done in the past. So this is the first one with Qatar LNG, which was done many years ago in Qatar. So this is the onshore gas plant, which was done with Shoda. Shoda was our partner, and we have multi-subcontractor for this job. So I want to share it with you after we show you the Coral FLNG project. So we give you a little bit of what is construction today, what we can achieve in terms of project and the complexity of the project.
At year-end 2004, Qatar Liquefied Gas Company Limited II awarded the Chiyoda Technip joint venture a contract for the construction of the two largest liquefied natural gas trains in the world. Thanks to additional contracts awarded in 2005 and 2006, 4 mega projects are currently being carried out in Ras Laffan by the Chiyoda Technip joint venture. 3 LNG plants, Qatargas 2, Qatargas 3 and 4, and Rasgas 3 for a total of 6 liquefaction units, and 1 gas treatment plant, AKG2. The overall value of these 4 contracts exceeds $15 billion. These LNG trains are located in Ras Laffan Industrial City in Qatar. The state of Qatar is sitting on the world's largest non-associated gas field, with 15% of world reserves. The Qatargas 2 site occupies approximately 6 square kilometers, the equivalent of 900 football fields. Given the size of these units, the execution of these 4 mega projects implies exceptional quantities and considerable means. A total of more than 700,000 cubic meters of concrete, equivalent to a cube with an edge of 90 meters. 133,000 tons of steel framework, the equivalent of 13 Eiffel Towers. Around 270,000 tons of machinery, equivalent to more than 950 Airbus A380 planes. The size of these projects is so gigantic that some of the underground pipelines installed measure more than 3 meters in diameter. At the peak of construction activity at the beginning of 2008, 700 cranes were needed and 70,000 workers from 50 nationalities, including 4,000 welders, were mobilized. As for LNG storage common to the 3 LNG mega projects, 5 LNG tanks have been built to store the liquefied gas at minus 160 degrees Celsius. A single tank can hold up to 140,000 cubic meters, the equivalent of 7,000 tank trucks. 2 berths for the loading of the world's largest LNG carrier, the new Q-Max, have been built in Ras Laffan port. More than 3,000 people are employed by the Chiyoda Technip joint venture in site offices and on-site for construction work supervision. So far, more than 550 million man-hours have been spent on the 4 projects. Safety performance on Qatargas 2 project is exemplary.
We achieved the job with outstanding safety performance well above international standards. Such a performance was made possible only because we put top priority on training, prevention, and daily commitment from top managers to workers on incident and injury-free principle.
Such a strong safety culture in Qatargas has become a model in the LNG industry and beyond. Qatargas 2 Train 4 was completed and handed over to the client at the end of 2008. Qatargas 2 project was inaugurated on April 6, 2009. Train 5 will also start in 2009. Each train will produce 7.8 million tons of LNG per year, allowing Qatargas 2 project to cover around 20% of the UK demand for natural gas. The total LNG production capacity currently under construction by Technip in Yemen and by the Chiyoda Technip joint venture in Qatar is close to 53 million tons per year, equivalent to around 1/3 of current world demand.
Okay, so just for your information, we have been awarded another project in Qatar called NFE, which is another LNG plant, which is bigger than this one. So it started, we have been awarded last year, and we just mobilizing the people in Qatar now. And, it's going to be for 4 years construction activity on this job. Next movie. So what I wanted to do is share with you some important activity we did on Core FLNG. So this is ongoing. This is a project which is on track. So I want to show you, this is a little bit different from the onshore plant in terms of construction activity, but you can see also it's more marine side, but you can see how big is this facility and what does really represent in terms of work. So this is this movie shows us the topside module, which is basically the block you build to provide the process and utility system on board. It was fabricated in Samsung shipyard here and installed by the Samsung shipyard using the big heavy lift crane, 8,000 tons. So this is was done in last year. In fact, we did all the installation of the module last year, so I should share with you the movie. So some you can see this is different from the onshore plant. We have to fabricate module. This is mainly steel structure with piping. One of the biggest module was around 5,000 ton. It was this with 8,000 ton shear leg cranes from SHI. This is one of the biggest crane in the world in terms of capacity of lifting. This is the reason why we choose to do this project in Samsung shipyard. Last video, this is the TMS, which is a tow MOA system, which has been was subcontracted to Sofec in Houston and built in Singapore. So this is showing the different, the integration of this module, this three module of this TMS, which is total weight is 8,000 tons. TMS, so sorry. Okay, so just few words on TMS. So this is a big equipment. This is one of the most critical. This is under integration in Samsung shipyard. It was really impacted by the COVID-19 in Singapore, and it was decided to send it to Korea to finish the fabrication here. It does require some change in terms of sequence, in terms of managing some activity which was supposed to be done in different way. We have to integrate the winch here, which was not the plan initially. So it was a lot of I would say engineering and change which were done by the team. So it shows that a project is not always, happening as per the schedule or as per the what has been signed. There's a lot of things happening during the project, which make it very exciting, by the way. It also, we have to be ready also to face this kind of challenge where we have to not to be surprised by change, by things which basically are not as expected, but we have to be ready to accept it and find a way to resolve it. So that's basically my daily job here, to resolve those problems and to find new different way to do it when sometimes you cannot do it the way it was already planned at the beginning. So this is also something you have to also to keep in mind, is to be very flexible, and also you enjoy a lot to deal with this kind of thing on daily basis. It keeps you very busy, I can tell you, and makes you like this job like I do. Okay. Okay, this is the end of my presentation.
Thank you, Christophe, for your presentation. It was really inspiring presentation, and I could, and I believe most of the participants as well could learn a lot from the presentation. And now we will start with the Q&A. Now we will start with the Q&A section.
Okay.
Yes, we have a lot of.
So I stop sharing my screen, I guess.
Yes, you can.
Okay.
So, well, the first one is from Ivandra Jofani. She's thanking first your presentation, and she would like to know if it's possible to proceed with the construction of LNG plant in a brownfield site, and what will be the needed steps for the preparatory work of the field, of the land. Sorry.
Okay, so if I understand, we call it brownfield project, I believe. It's when you have to work inside existing gas plant, correct? Specific question, correct?
Well, I believe yes.
Yeah. So for this, we call it more shutdown, in fact, or more, So yes, we can do it, of course, and but there's a clear difference, because we are not more in our project where we can do whatever we want. It's basically we are totally dependent on the operators, and we have to basically follow their process and procedure. So for the main things will be that you will have to work through permit to work, and each activity will have to be captured under permit to work. Okay. You will have to put in place isolation. So basically, when you want to work on a system which is live, you have to isolate the line, you have to isolate the system to make sure you don't have any risk of gas leak or any chance of power issues. So this is basically a totally different project. So we have to comply with the operators' requirements, but this is very, very, I would say, difficult to manage, because you don't depend anymore on yourself. You depend on other operators who give you the access to one area when he wants to do it, depending on the operation. So operation is basically driving the project. They tell you, okay, you can work on this line, you can work on this equipment, but for that you need to have a permit, you need to isolate the line, you need to isolate the system, and for that you affect the operation. So for me, this is a new project. This is different, way to approach, but this is also very interesting. But for me, I would summarize is, yes, you need to work under the operators' requirements, permit to work, isolation for every activity you're going to undertake. And this is also require very, very precise planning. Normally, shutdown planning or this kind of activity you're doing per hour. Per hour means you have to avoid to disturb the operation and the production. You have to basically you have a slot given by the operators, and you have to stick to this slot. And you have to make sure you develop a very detailed schedule and to comply with this shutdown or slot.
Okay. So in case of, you have mentioned that we need to work regarding to the permit to work, and this, I think that it's linked to the license. I don't know if I'm mistaken.
No, not really. Okay. No. Permit to work is set up by the operator. who put in place, some rules to work on. We do it for commissioning here as well. And for info, you just have to basically specifically explain what you're going to do, the risk assessment, identify all the the potential risk you have. So this is operator which give you all these requirements. So this is nothing to the license really. It's operator or client who has normally in his operation manual all these steps. We start by the permit to work, isolation, which is basically as you a detailed procedure, detailed schedule, the tools to be used, high-risk activities, to do some kind of job safety analysis. So to document all this activity to make sure you don't put at risk the operation.
Okay. All right. I believe, Ivandra, your question is replied. If not, feel free to raise it again, and Christophe will reply to you. The second question, I think it's for me. It's Eliane Tembe. Is asking about how it will work and how can we choose the themes for the university essay contest. Well, in the slides that I presented to you, there's an email, and there's also the Mozambique Gas Summit website. So there you can find more information of the themes. So in the email you can raise the question to the Mozambique Gas Summit, and then you will get your reply on how you could search or choose the themes that you will be doing the essay for to participate on the 7th edition of the Gas Summit. I will move forward to another question from Ivandra Giovanni, and she's asking to you, Christophe. As per your experience, she would like to know what are or were the main challenges that can be faced and need our attention during the construction of FLNG plant.
FLNG?
Yes.
Well, I think safety for me is probably one of the safety is important, because you when you start to assemble all this equipment, you are dealing with a very high tall module, very congested area. It's designed for operation, but it's never designed for construction. So you have a lot of access issues. So safety is probably one of the main challenge we have. Again, this is not a big surface, so you have basically everything is very, very congested, and the access is very difficult. So you have to imagine when you deal with construction activity, when you need some space to bring your materials, to install your spool, it's always difficult to work in a very, very small area. Quality as well and preservation, I think I would say that today is we probably don't put enough attention about the preservation of this equipment. I mean, the way when your equipment arrives is in a box, is well preserved, and the nitrogen or whatever. But once this equipment is open and basically it's outside, outdoor, it gets really very, very quickly, it can be damaged by humidity, by the rain. So this is something which we are facing today here. We found a lot of equipment which are rusted. Hopefully some can be just, clean and repair, but some, when the integrity of the equipment is affected, you have sometimes to replace the part. So I think quality and preservation is for me a key challenge. After that, for this specific project, my challenge here will be you are dealing with a lot of people, a lot of subcontractors, and so I think it's to find the balance between all these actors, all these key players, and to make sure basically you are giving to everybody everything they need to perform their job. I mean, it's important that you don't put too much attention only on Samsung industry, and you give him all the information, you support, but also give also your support to everybody to make sure they can also achieve their performance and the task. And this is not easy when you're dealing with many people, many subcontractors to have this balance where everybody got what they need to do the job, and you don't penalize someone, because sometimes when you basically give something to someone, it gets some kind of benefit, I would say, to work, and you have to make sure you balance your support to everybody. Last challenge I will say is for me is the difference of culture can be sometimes a shock for people when you arrive in this kind of project, when you have a different way of working. So you're working from people from Asia, but also from Middle East, from Australia, from US, from everybody, from everywhere. So the challenge is to make sure you stay neutral and you basically understand each people, and the culture is not becoming a kind of a blocker, and you can basically treat everybody as everybody, okay, as human being, and there is no difference. So the culture shock can sometimes be difficult. For me, I've been in this industry for many years, so I know. But when you start, you have to accept sometimes things. Some people can react, the different way that you imagine, but you have to accept it because that's the way they live and that's the way they behave. Okay. That's probably another challenge, especially when you start in this industry. That's more or less what I can see, but I can speak for 1 hour for you. But I will probably maybe give you this few challenges for me as the main one.
Okay. No, it's well understood, and thank
I'm
you.
not sure if this answers the question. It was more a personal question. She wanted to know about challenge for herself or for himself or just for the project. I was not sure of the question.
Well, the question is in fact the challenge that can be faced, and it can be for the project itself, can be the challenge that you may face during this your journey. Yes, could be like that. But for yourself, I prepared the question also.
Okay.
So yes, so I will take opportunity to ask you about that. So for yourself, what was the main challenge that you faced first when you entered in the construction field as a construction engineer? I believe that this is what you started. So what was the challenge?
Okay, so I think I remember very well. So you always have a problem when you arrive. It's how the people, we of course have many years of experience. They look at you as a stranger, as someone's coming from another planet, and they normally don't accept you because you basically are just coming and try to give a bit some advice. But I think you have to accept at the beginning to learn, to be ready to do tasks you don't expect to do, and basically you need to talk to the people and basically use this opportunity to learn from them. It's very important. Okay, so for me the challenge was to be accepted by the people. We have sometimes 20 years experience, and they don't see sometimes young persons coming as basically a kind of good things, but you have to basically explain why you are here, what is your objective, and basically get this opportunity to learn from them. It's really for me the main challenge. Get the trust, respect people, and I think you probably get whatever you want. But I think this is something you should be careful because you can fail. You can fail in a way that you cannot, maybe you can be rejected. You can be basically, you don't feel part of the team. You don't feel part of the project, and they can maybe push you a bit aside, and you probably will fail. So to avoid that, you basically to accept, to listen, to learn, and again, you respect the people, and you basically you get whatever you want.
All right. Okay. Thank you. And I think that you have summarized two of my questions, where one is the main challenge that you faced, and the another one is the advice that you can give for the young graduated or the young engineers that needs to go in the construction field.
Yeah.
So I believe that those two was very well answered.
Yeah.
Thank you.
So yeah. So just about the advice I will give is for me, I try to present, in a very short time, the different, discipline, the different areas. I think you have to choose a job where you feel the most comfortable first, what you like to do. We show you the safety, quality, construction, with cost control, with planning. There's a lot of things. Okay, so you have to choose what you like to do. And after that, it will depend. So how you want to progress, but that's probably what you need to do first. And I think you have to don't be shy, ask questions, and you need to develop your personal knowledge as well. Together by having a professional activity, you need to basically continue to progress, to learn by doing training, reading book. But basically for me, this is a curiosity. You have to be curious, and willing to learn. I think that's very important. And also is choose what you like to do. Don't choose a job because you are forced to do it. Choose what you like to do. If you don't like to do something, say I don't like to do it. No point to do something you don't like to do. And really enjoy what you do, and I think you will succeed. You will succeed.
All right. Very inspiring word. And thank you. So I will follow with the next question from Evandra. She's asking for the progress measurement of the schedule. She would like to know how is the weight defined for the milestone or activities? Is it defined by the client, or it's an internal definition by the consortium teams or areas?
Okay, so consortium define what about the consortium write a procedure for project measurement, which was reviewed approved by the client. Okay, that's what happened. Okay, so the clients do some change. So basically, we did the one for engineering with GCC, and very simple. Engineering is basically deliverables, man hours.
Okay.
So basically, you have a deliverable, you get 100%. And you have so many man hours for one deliverable, you measure the progress service, you get paid when you have finished. For construction, SHI did it based on the weight. Okay, that's also another way they use the quantities to measure the progress. Okay, which is basically meter, kilogram, tons.
Okay,
That's the way they do it. Yeah, very simple. But again, so each of the consortium partner has developed their own weight in progress, put it together, submit it to the client, which basically gives their approval. Okay, but again, to give you an idea, our engineering scope is more based on man hours, deliverable, of course, and construction is based on quantities. That's basically the big difference you have to have in mind.
Okay. All right. I think Evandra, your question have been replied. So we'll continue. There's anonymous Tindi that is asking, as we have seen from the presentation, it's quite common to have multiple companies originating from different countries. How are the construction and engineering phase handled when it comes to selecting and enforcing standards, ISO, API, or etc.? Are they also part of the terms of contracts, or it's a different framework?
Yeah. So good question. So in fact, our industry is driven by American standard, which is used all over the place. So most of the clients, I'm going to mention a name, but Chevron, Total, BP, Shell, they use American standard. So it's quite common, and all the subcontractors and contractors, they have been qualified through a process, which basically says they comply with this standard. So when you receive the client requirements, most of the time they refer to API, STM. This is standard. Okay, and normally everybody has been qualified. With audit, DNV, BV approve the company based on their basically performance, and they comply with the standard, which is oil and gas standard. In fact, it is part of the contract. Okay, and in the contract you have sometimes 5-6 pages of all the standard, all. So sometimes sometimes they choose different standard. You can go to British standard, for instance, for scaffolding. It happens sometimes. It depends on the country, the client, but most of the time is for guys is American standard. Okay, and everybody knows if they want to bid for the job, they have to basically be able to provide a job as per this standard. So it's part of the contract.
Okay. Okay. Following that question, I have one also linked to that. So basically, there is a standard that needs to be followed when you have one project to develop. And then this standard can come from the client itself, as you already mentioned, that the client, the Shell, BP, Total have used some standards. And then there's, for instance, we can consider SHI or the consortium as a contractor. And they have also the standard that they use for some particular case, can be for equipment, can be for steel structure. And then there is a law that it can be, I think, I don't know where it will be located, how those, how can I say, how it's considered. First, there's a law itself that can define how the things can go in each country, for instance. And then there is a standard that can be issued by the client, and then there's your own standard, you as a contractor, the one that you will build the project. So how is it considered in terms of the weight? Who is above what in such a case?
Yeah, so we don't issue standards. We issue procedure or guideline, but we don't issue standard. We take the client standards, basically roll it back to subcontractors. We don't modify anything. We stay in this with the client requirements. So we don't write standard or specification. We don't do that. We don't do that.
Yes.
What we can do is sometime we can. It's happened. We can write specific construction procedures, which can be added to the subcontract. It can be done by our team to do it because we want to do it in a specific way. But normally, we don't write standard or whatever. We don't.
Okay. All right. Okay. Thank you for your reply. And there's also another question. What is the most complex phase in the construction?
Well, I think I'm going to answer straight away is what we are today with. When you overlap construction, commissioning, operation, which happening now, this is the most complex. Because it's difficult to manage all this. We call it CMOPs, simultaneous operation, where you have construction want to do some work here, commissioning wants to do some work here, and you have to manage this together. So basically, it's when construction works on their own, it's okay. I mean, they have the place, they do the way they want. When commissioning start to take over, when basically they start to take some equipment, start to energize, where the difficulties start, where there's some priorities to be given to the site, and is where sometimes the clash occurs. So for me, I would say end of the construction and the commissioning is maybe at full speed is where is the most difficult, because it's where I think each activity sometimes overlap and block each other. That's creating a lot of conflict, and it's difficult to manage sometimes the activity without impacting the other one. That's probably for me the most challenging. So today on this job, for function, we have construction is finishing. Commissioning is full speed, and O&M, operational maintenance, are starting to take the ownership of equipment. That's really a complex management of the site, because you don't have only construction, but you have two other entities working in the same place at the same times. So that's creating a lot of conflict issues. The problem also is to deal with safety side, where we have to energize equipment, we have chemical cleaning, we have a high pressure leak test at the moment. So this is really the most challenging, probably the most difficult today for me.
Okay, so I think the question is answered. The next one is what kind of foundation are frequent in your project?
Foundation means?
Well, I will try to to understand the question, but I think this is linked to maybe can be for the civil work.
Oh,
Or also can be if you develop a steel structure and you need to put it can be in the deck of the FLNG. So I think he's considering that maybe
okay.
those two cases.
So FLNG is very simple. So we have foundation, which are steel foundation. Module are sitting on four columns, piers, if you want, which support the weight of the module. That's basically very, and this we call it stools, is directly welded on the hull deck. Is transferring the load to the hull deck. So this is very simple. Okay, I can share you some picture or movie if you want one day. For civil works, it's different because this is underground, so it's basically sitting on concrete foundation. Can be beams, can be a footing. So any kind of foundation, it depends of the weight, it depends of the geology of the soil. It could be on pile as well. Sometimes I did a job in Vietnam where we have a landfill. We have basically each equipment was on, even the drain on pile, because basically the soil was bad and we have to go very deep to get a good foundation. So this is depending of the soil, the weight, but beams, piles, footings, all kind of foundation, depending of the ground, obviously, and the weight.
Okay. All right. I believe it's answered the question. So the next one is what is the order priority of construction in terms of structure, instrumentation, and electrical in the vessel?
Yeah. So very simple. I think it's you can imagine. So first is the structure. Basically, the structure is your house. I would say this is what's going to carry all the equipment, piping, and this is what you start first. So in Samsung, here for FLNG, it was done basically in a kind of deck. You imagine you have a module is 4 or 5 decks, and they build the deck separately in a fabrication shop. And what is the particularity of Samsung and the shipyard in Korea? They also not only building the structure, but also they put all the pipe support. They try to also do some piping works. They also put the electrical support. So they try, and I think the key for the message I want to pass is you have to maximize your prefabrication for a successful project. Do as much as you can on the ground before to lift. So this is basically what Samsung do here, or Hyundai or Daewoo. They do as much as possible in the fab shop. When it's done, they send to a painting workshop and they paint everything. One go. Once it's done, so imagine you have basically your structure, you have your pipe support, your electrical support, and a bit of piping. Okay? The big one in general. And once it's done, basically they do the deck assembly here, deck stacking we call it. They put together the deck and the column. So basically they build the module on a key. And when they start at this time the piping installation and the equipment installation. So basically, imagine your deck, you put your equipment, you leave your top deck, you continue like this, put your equipment, and at the same time you put your piping between the equipment. So structure fabrication, after deck stacking, equipment installation, piping installation. Once it's done, you start to pull your cable. And you start your instrumentation come at the end. When you have all your piping installed, when your all equipment is installed, you do your instrumentation and all your cable connection. Let's give you the sequence. Is it clear or is it?
Well, for me, it's clear.
Yeah.
I believe that for the one that raised the question as well, it's clear. So the next one, it's what are the first aspect you look at when you want to start managing the construction scope of a project?
Well, for me, the organization, how you set up your organization. with your partner first, because you always, on this big project, you always have a partner.
Okay.
It's always, so you need to basically engage your partner. Okay. So, and build your organization. This is the first thing you have to do, is basically based on your scope of work, client, you have to build your organization. It takes long time to build a proper organigram, which works, not only a paper organigram, but works in terms of the right person, the right place. And once you build your organigram, is recruitment, how you select your people. So it's not easy, because sometimes you have to recruit outside. So this is basically for me, set up the organization and recruitment of people. This is for me the first thing I look when I start a project.
Okay, no, it's clear. It's clear, and thank you. So the next one, could you give example of construction optimization that can result in major cost and schedule reduction?
Well, for me, there is a simple thing. Modularization for me, this is one of the best way to optimize. Is, again, I explain, you build something on the ground, and you basically lift when it's all integrated. So the aim is, of course, it was happening on a core FLNG. Basically, you build something and you have a minimum work to be done in the field in terms of integration. So it's what's happening on the module here. You try to, I will say, ASHI does it very well, is they always try to minimize the work in integration by doing only one single lift. Avoid, basically the integration scope by doing as much as possible of fabrication in the ground and installation in the ground. So to answer your question, is basically modularization. Optimize your modularization and do as much as possible of work on the ground before to lift your module for the FLNG. Okay, that's for me what I will consider. Is that also for onshore plant? Fabrication, prefabrication is probably the key in terms of optimization of schedule and cost today.
Okay. Thank you. And I get another question from Armando. He's asking, have you returned any material from non-complying with the specification?
Oh, yes, we do. Yes, we did. We have just for instance, we have on the 2 MOA system, we have some valve delivered by a supplier. I don't say the name. We have basically a drill. Basically, to install the valve, you have bolts, nuts, and he basically drilled through the valve, not inside the body. It drilled through the valve, but the valve as a whole. And this material has been basically rejected. It was accepted first previously by the SOFEC, the contractor. But it was rejected here when it was delivered. The only problem is only 160 valves. So can you imagine 160 valves? The delivery time is 16 weeks. So this has to be replaced offshore in Mozambique. So not a small job. So this is happening, I would say, sometimes, because also you're putting so much pressure on your vendor in terms of delivery schedule that sometimes they don't do everything as per the specification, and they're basically doing mistakes. And also you will find that to lower the cost of fabrication, sometimes what happens, you place your purchase order with a name of a supplier, but in fact they have a sub supplier. And they have a lot of components coming from other places, other country, whatever. And you find sometimes one specific parts which was fabricated somewhere in the world in a workshop which was not even qualified for this kind of job has been used, and you find this piece is not complying. So it's happening. I've seen on this job few cases, and it's before as well. So it's happening more and more often, because I think we put in so much pressure on the vendor to reduce their costs that they have also some time to take some shortcuts.
Okay. So linked to that question, there's also another one. You have mentioned that sometimes you can put a lot of pressure to the vendors to deliver something, and then this may occur this failure in terms of specification. And yeah, the question is that how do you deal with the deadline, knowing that construction involves many process?
Try to understand your question. Sorry, just
So he's asking, how do you deal with the deadline, knowing that the construction involves many process? So this process can be different departments. I believe that the question can fit more on this case, different department and different section. You can have structure fabrication, you can have piping activities to be done, you can have electrical instrumentation. So how the deadline
deadline means schedule or
schedule? Yes, in terms of schedule.
Okay. So what one of the things we have done on Coral FLNG is probably something which also has contributed to the success of Coral. Is we have done early engineering. So we start engineering very early to give time to the supplier to provide the equipment, excuse me, and to deliver way in advance. Okay, to avoid to de-risk the construction schedule, because the shipyard in Korea, if you don't deliver the equipment on time, they will claim after for delay and they will extra cost. So you have to make sure your equipment arrive in time. So for that, we start the early engineering. I think it was started, I think the contract was awarded in 2017, I think, and we started early engineering earlier. So we secure the big equipment orders, the general electric equipment, compressor, generators. We also buy, for instance, extra valve, because when we start the engineering, we are not 100% sure of the quantities. So we have ordered extra valves. We knew it was a risk. It was a cost application, but we knew that it will help to secure the delivery and to make sure we can deliver to the shipyard. So we de-risk the construction by having this early engineering, early procurement, and also we also try to package it. We also try to basically minimize the number of vendors. I know sometimes it's not easy because you have a different product, but we try to avoid to have too many vendors, because you want to have the same quality standard, you want to have a control of your schedule. So we also try to basically have a big PO like we did for the instrumentation system and the MAV system, to make sure that you are basically not putting the project at risk, having different delivery because one of the vendors fell or whatever. So we try to make it more simple in terms of management of the PO. And after what we did, we work with SHI, as explained, we at early stage by preparing the sequence and to define what we call the ROS date, required on-site date. So we give to SHI a schedule. We ask them, okay, tell me when you want the equipment to be delivered. And they fill up an Excel file as I want the equipment to be delivered on this date, on this date, on this date. We went to the vendor and we ask them to put this date in. We put this date in the contract. So we want the equipment to be delivered on this date. That's the way we deal. However, COVID happened, and we have some vendor which is impacted by COVID in India or whatever. So some equipment, some material was delivered late. So we have to do air freight. Most of the time we do air freight because it's the only way we can mitigate the delay. And SHI has to find a way to install the equipment or this valve or whatever in a different way they planned before. But this is it's not happened a lot on this job because we have, as I explained before, early procurement and we escaped COVID. But for some material, we have to air freight and we have to basically sometime put more money on the table to deliver quickly the equipment or the valve or the fitting, whatever. That's it.
Okay, thank you for your question. So there is a last two question, and the first one it's she's greeting first, and is asking beside the social and economic benefits of the project of this dimension during the construction, Are there any environmental and social impacts? And how does the company deal with that?
In Korea or in Korea?
Well, I believe yes, because it's during construction. So
Okay.
I believe yes, it will be Korea.
Yeah. So social impact, I'm not sure to understand what does it means. Maybe social impact.
Well, she's asking more about the environmental and
Okay.
social as well, but
Well, environmental.
go.
So environmental is South Korea has a strict law for environmental. So for instance, in a yard, you cannot throw anything in the water. You can, but it has to be basically specifically to a certain standard. So we have this issue here during the commissioning phase. We are basically rejecting dropping water in the sea, and we have been asked to stop because the water was not clean enough. So they are very strict in terms of water, noise. We have some issue, and the yard is basically surrounded by housing here, house buildings, and sometimes people complain about the noise. So SHI has also to comply with the regulation for noise, maximum noise. So this is really a strict rule in Korea, and people are complaining quite often if there's things which are not correct in terms of noise, in terms of water quality. If the fisherman will let you know quickly if there's a problem. Smoke as well, CO2. So this is also all controlled, so we cannot basically reject CO2 or too much. So this is really quite, I would say, there's a rules, there's regulation, which is part of the Korean government, and the yard also is putting on the top of that additional requirements, which are really in place in this yard. So I think today, the South Korea being a developing country, you can imagine they are really, really very care about the environment, and they don't let anybody to create pollution. So this is really for me. I work in different projects before different countries. This is probably for me the best in terms of environment I've seen so far.
Oh. Okay, thank you. I think was the challenge for you to comply with that. But I believe that you are taking all the measurement to comply with that, specifically for the environment. And that yes, this is one of the most critical part in the world, if you can see. The last question is from Eliane Tembe. She's asking, in terms of construction, what is more difficult to do? It's to build in concrete or in metal, or do the metal work?
Yeah, just to come back to what I was saying about the environment, I think in Korea, what I was referring to also the waste management. They really have a very good process in terms of waste management, which what you do in your house happening in the field here. So really, they segregate the waste, and this is something which is really for me. Again, I've never seen this in the world before. Never. Okay. And your next question was, sorry, next question was.
Well, the last question, it was in terms of construction, what is more difficult, build with concrete or with metal?
Well, in offshore, because I'm offshore, concrete is not very the most common way to build because it's heavy and it's not really the best way, but to maintain. But I will say for me still. It depends. It will depend. It depends of what you want to do. Is a building is concrete, of course, because it's cheaper than the steel probably, and offshore is a steel because this is the lighter. It's easy to maintain and it's the best way. So I think it's depending of the project and the country and the client. So this is for me not concrete is better or steel is better. It depends of all the environments. the client, your specification. But for me, generally speaking, when you are on the offshore, is a steel. Steel is an easy way to do it. Concrete is too heavy, it's too difficult to put in place. And for me, onshore plant is a mix of building in concrete, foundation in concrete, and normally when you basically above the ground, you build in steel because it's much more easy to in terms of fabrication, I think. Steel you can fabricate, as I explained before, basically in somewhere you can build and put really as ready as with full structure. Concrete is more difficult, even if it can be done, but I think it's more heavy, more difficult. It means you need bigger cranes. So I think it's I would say probably for our offshore is steel structure for sure, and for onshore plant is a mix of concrete and steel structure, depending on what is the most economic, I would say. Economy is driving a little bit the choice, depending on the country and where you are. Availability of concrete, cement, steel, it depends on all these things.
Okay. Thank you for this explanation and replying all the questions. I believe that this is time to close. I would like to thank you, and if you give, could you please give a few words of on this particular case, can be on the construction site, or can be the inspiring word for the guys or the ladies, that because the MWE it's more linked to bring more ladies to this environmental.
Mm-hmm. Yeah. So I will say thanks first of all to give me the opportunity to share my experience with you and this presentation. I have the opportunity to meet a few of you in Korea, in the last couple of years, and I was very happy to see how much energy, how much willingness your guys want to really succeed and are proud of basically to be in this industry. So I think it's really give me a lot of inspiration. In terms of I think future for all these young women, I think there's a big opportunity for you to come to our industry, our company, Technip Energy or the company. I think this is for me Mozambique has a chance now to have a big gas resource, and I think you need a lot of people, and I think it's a good opportunity to learn, to build your career, and also to basically represent your country in this world. So I think this is for me I try an opportunity you probably never think 10 years ago. You are young, you just have your degree, you are basically want to move, you want to see other things. So I think this job offer you also the opportunity to go in other places in the world once you have enough experience. So I think this is for me a fantastic career and fantastic opportunity for you at this time to go for it. But it's challenging, but this is very rewarding as well because you learn a lot. And again, I don't know if you like I would say to have the same thing every day. When you wake up, you do your job, you do your work, you come back. In this industry, it's never happened like this. Never. You always have different things happening every day. In fact, it's never as planned. That's sad to say sad sometimes, but it's not as planned. You always have things happening which was not planned, and also you have I would say you are dealing always with people, which makes you more exciting. You have different people, different culture, different characters. So that's really a permanent dialogue, exchange. And you're moving all the time. You discover new people, new projects. So I would say this is for me a fantastic opportunity. You have to make it happen. This is for your country and for your future. You have to make it happen. So come and join Technip Energy first, because I would like you to work for us. But this industry has still a lot of things. We're not going to move to offshore wind farm and hydrogen tomorrow morning. We have a lot of still gas and oil to be discovered and to be produced. So I think this is the place to be, Mozambique. You are basically at the best location today. So go for it.
Okay, thank you. I believe those inspiring words have reached all the participants. And yes, thank you one more time for your time to join us and to explain your experience and to share this beautiful knowledge that you have in terms of construction and the industry.
Yeah. If you need something from my side about some specific, because again, this presentation was not very technical. If you want some specific things on this project, on the sequence, method, procedure, don't hesitate to contact me through your network. I will be happy to chat with you.
Okay, thank you.
Okay.
Thank you.
My pleasure.
All right,
Okay.
bye-bye, and thank you all for these attendance. And yes, we will end now.
Thank you very much. Have a good day. Bye-bye.
Thank you as well.
Obrigado. Bye-bye.
Merci. Merci.
Bye-bye.